Hello, everybody. Today I'm going to present RasterID 2020 and show some of its features which might be useful for your day-to-day tasks. So, without much ado, let's start our demonstration. This is the overall layout of RasterID, how it looks. We have got different menus like File, Edit, View, Colors, Image, and Tools. This software is mainly designed to refine and index raster images and raster drawings. So let's start by opening a drawing. Let's find out some drawing here. In the first part of this demo, I'm going to show how to refine a normal monochrome image. Okay. So as you can see, this image is a skewed image. It also has got a number of flakes or pixels or what you can say, the speckles as impurities. Also, this drawing seems to be scanned in the reverse order. That is, it is flipped. So we can make changes to this drawing and let's see how we can make this drawing more perfect. Okay. So the first and foremost, let's deskew this drawing. Here we go to the image panel and then select the auto deskew. Auto deskew will automatically check the skewness of this drawing and deskew the image. So let's do it. Okay, fine. So we can find out this image has automatically been deskewed. We can also use the manual deskew in case the automatic deskew doesn't work as intended. It might sometimes occur. Okay, now let's flip this image to correct the orientation. So I'm flipping this image right now. Okay, the image has been flipped, as you can find out. Now this image makes sense. As we can see, there are a number of speckles over here, or the impurities, as you can see. The speckles needs to be removed from this drawing. This can also be done through a tool called the speckle remover. So what you can do, you can remove the speckles by selecting an area, or you can remove the speckles from the entire drawing in one go. It starts removing from the lowest pixel size and keeps on increasing the size when we use the auto estimate button. So let's select the auto estimate button and then we click on apply. Every time we click on apply, the lowest speckle size gets removed. So let's do it one by one. As you can see, most of the speckles got removed. Let's see if there are some more speckles. Okay, as I can see, there's a speckle over here. Let's try to remove this manually. We can select an area. Then we can click on auto estimate and then we can click on apply. Okay. So this is how we can refine a monochrome drawing. There are various other tools as well. We can thicken or thin an image. We can smoothen an image. There are flip, rotate, and mirror options and 4-point corrections. We can also resample and resize images if we wish to. Say we want to crop the image. There are several options for cropping as well. We can crop by rectangle. Say, for example, we want to crop this drawing, then we can select a specific size for this rectangle. Let's make it a bit bigger. This is cropped using the tool called the crop by rectangle. Let's undo the changes. We can also make changes we can also crop it through the work area or through the frame. This automatically selects the frame and then crops the image as accordingly. So let's do it. So as you can see, the image has been cropped according to the frame. Let's undo the changes. For undoing the changes, we simply need to press the Ctrl plus Z button. Now we can also thicken, say for example, we need to thicken this or make the lines appear bolder. Then we can use the thickening tool. from the menu. And then we can also mark the thickening direction. We can either mark it vertically or horizontally or in both directions. Let's mark both. And we allow two number of passes, or rather, let's make it one, and then click on apply. So as you can see that the entire image now has become bolder. In a similar way, we can also make the image or the lines appear thinner. So let's include one pass and then click on apply. And we can see that it has become thinner. In this way, according to the relevance of the drawing, and in case we want to make the lines bolder or thinner, we can choose the specific option as desired. So let's do some more examples. We have got something called the 4-point correction. So let's see how this works. Close this drawing. We don't want to make any changes. So now let's open another drawing. For example, this is a colored image of a book. So say, for example, we need to make an orthogonal projection of this book. We can use the 4-point correction. So let's click on this tool. Okay. We select the frame size. Let's keep it as according to the drawing. It finds the nearest frame according to the drawing. And let's now crop the pictures. To select the 4 corners of the drawing to be selected. Let's do it like this only. And we click on OK. So we can see that this actually shows a 4-point correction of the drawing and gives an orthogonal projection in the XY plane. Okay, let's remove this now. Let's do something called the image stitching. For image stitching, we can go into the tools. As we can see, there are various other options. We have the image stitching over here. Let's open a drawing. Okay. So we need to stitch 2 images. We have one image, this one. This one is one of the images. We need to stitch it with another image. Let's open another image as well. What we need to do, we need to click on the image stitching option. And here we will open another image. Let's check this one only. So here, as we can see, there are 2 images that needs to be stitched together. You may note that these 2 have a different orientation. They may be of different size, but these 2 images are likely to be stitched, to say that they are a part of a same drawing. So they can easily be stitched together, no matter what their orientations are or the sizes are. Okay, for that we need to take 2 reference points. So we need to select on the select reference point button. So we get 2 markers, one in red and the other in blue in both the images. Let's highlight the images. You can see this is the red marker, the blue marker of the first image. Similarly, the red marker and the blue cross on the other image. Now, in order to stitch 2 images, we need to have at least 2 reference points which are common to both the images. In the first image and the second image, let's see what common points we can get. We can choose the Iceland is common in both. So let's do one thing. Move the first one to the tip of the eye in Iceland. Okay. This needs to be moved here as well. The red cross needs to be moved at the tip of Iceland, tip of eye of Iceland. Pretty much. Now let's move the blue one somewhere. Let's see what other common points we have. Let's take this point, the Atlantic Ocean. Let's move it to the T of Atlantic Ocean here. Pretty much now the blue cross in the other one needs to be moved as well. So let's see here, blue cross. We need to move it to the same reference point. Okay. So pretty much, so the 2 points or the reference points are aligned in both the drawings. Now what we need to do, we need to click on. So let's see how this happens. Okay. Let's do a preview first. Okay, so this is the preview. The two drawings are actually merged together. Now, since both the drawings are merged, we can check through the layer options, which one gives a better representation. The first image above the second or the second image above the first. I think the first one shows a better representation. Now we click on OK to finally merge the two images or stitch the two images. So here we go. This is the merged image. Similarly, we can use this as the primary image and then merge it to another one and so on till we can make a full-fledged image of the drawing. This is how image stitching works. We have several other options like multi-page TIFF or PDF maker through which we can merge several PDF files or PDF pages together into a multi-page PDF. Or say, for example, we have several TIFF images. We can merge them all together and make one single multi-page TIFF images. Besides in the color option, we have several other features like brightness, contrast, hue, saturation, luminosity, color equalizer, separator, color reduction. We can binaries or sharpen image. We have gamma correction options, inversion blur, adaptive blur, and several color filters. Now, let's do one thing. Let's open an image. So as you can see, this is an image of a wagon. It has got a title. RasterID, as I already mentioned, is also an indexing software. So what it does is it has got an inbuilt optical character recognition tool through which it can actually recognize the title block and save them in an indexed file. For example, in an Excel sheet or in a comma separated value file or in any of the several databases available. So what we are going to do here, we are going to use the optical character recognition tool to recognize a title block in a monochrome image. Okay. So in order to do that, first, let's do one thing. Let's click on the title block. Here, as you can see, this is the title block area. So we need to create a template for the title block. So let us create a template here. We need to first figure out the title block area. Now we can mark the different fields within it. So let's rename this field as description. Let's rename this field as scale. And let's make a third field. Let's rename this as drawing number. Okay. So our title block template is more or less done. Now we need to save this template somewhere. Save it. Let's rename this template as, suppose we rename this as TTT, TTT.ttf. This kind of files get saved with the extension or as of TTF. Now, since we are doing a title block recognition, it needs to be outputted in a separate file. So RasterID has got several options. We can output this file as an indexing output in MS Excel, in a comma separated text file, in MS Access, SQL Server, and MySQL Server. For the sake of simplicity, let's consider MS Excel here. If we want to index this output in MS Excel, we need to choose MS Excel and click on this Customize Excel Output button. Here, what we can do, we can choose a Excel output generator and create a template file as well. So we need to save it in a file. So we need to take a file. We choose a new file. Let's save it somewhere in the desktop. Choose the desktop option. Let's give it a name as TTT. Now the appending mode, every time we include a new set of data, it would be appended in the existing sheet. So here we check the existing sheet number. We keep it as 1 because it's a new Excel file. And we do not need to specify the column header every time we save the data. So we do not specify the column header. We also attach the title block in the sheet. So we keep the checkbox ticked. Now what we need to do, we need to save this template. Here as well, we give the same name as triple T in caps. And the extension is .osf. We save it. We click on OK then. Now that both the templates are completed, the template for the title block and the template for the indexing output, we can safely click on the button OK. Once we do, a title block manual editing dialog box appears. So every time you do a title block recognition, this box or this manual editing template may or may not occur or appear as according to your customization. If you want this to appear, it will appear. If you don't want this to appear, it won't appear. I'll show you later on how we can customize this option. For the sake of demonstration, I've kept this option as checked because every time we do a title block recognition, we are not always sure that this would yield the right result. So on the go, we can make the necessary changes if required before finally inputting the values into the indexed or the output file. So here, as I can say, the first field had the specific dialog. Let's see what the title block recognition has done. So it's perfectly fine. We press Ctrl Enter and then go to the next option using the down arrow key. In the scale, we can see that something else, undesirable characters have appeared. So we can go ahead and make changes over there. Also, some of the title block recognitions are not as intended. So we can make changes here on the go. So we make the changes. Press Ctrl plus Enter, and this will save the changes in the output. Then we go into the drawing number, make the changes if required, and then click on OK. Once we click on OK, a new file with the name TT.xls would be created and it would contain this saved image. So here the message says that the title block data has been saved or updated in Excel successfully. So let's open the file and see what kind of updation has been done in the newly created file. So let's find out where this file is. Here it is. Let's open it. Okay. As you can see, the description, scale, and drawing number fields and their respective values for the first drawing has been added. Additionally, we have the path, which actually shows the part of the file which we had processed or which we have indexed. And then comes the title block field, which has a block embedded in the Excel sheet. So this is how this appears. I don't want to make any changes right now. So this is how we can make changes to a title block, or rather we can make a title block recognition for a single file. Now, this can also be applied to a number of files. Because RasterID is a tool in which we can do macro processing, which means we can do we can process images in batches. So for title block recognition as well, the batch processing mode is enabled. So we can also do a title block recognition for multiple files, which necessarily have the same kind of layout. So let's find out what kind of files we have here. So we can see that in this folder, we have several files with the same title wagon. So what we can do here in this demo, we can demonstrate how we can do title block recognition for multiple files in a batch. Okay. So let's start. In order to do a batch processing, the first thing which we need is a script. A script is necessarily is a macro which contains a number of commands, a number of tools which are executed one after the other on a specific drawing. So in order to do that, we go to Tools and we click on the Script Studio. Here, as you can see, there are various commands like open, close, save as, print, invert colors, different type of filters, then cropping options, skew options, mirror options, rotating, and there's several host of image processing tools that we have in RasterID. So here, since we are going to do a title block recognition on all the drawings, so our script would be relatively simple. All we need to do is we need to click and drag the title block recognition PDF. Now we need to specify the title block template and the title block output. The title block template, we have already created one, which is TTT.TTF. We open it. And for the title block output template, we again click on here and select TTT.OSL. So this is essentially what we need to do in order to create a new script for title block recognition, and we can save it here somewhere. So for the sake of simplicity, we give the same name, TTT. This comes with a extension of .tpl. We save it. Now we can go ahead and close it. So now our script has been done. All we need to do is process the files in batches. In order to process files in batches, we can either use the batch processor or the virtual scanner. We can use either of these two. Let's use virtual scanner. In this tool, what we need to do, we need to scan a path or choose a path from which all the files from that path would be taken. We open it. Let's find out the path. This is the path. Let's try images. Okay. Now we need to choose a scripts file. In our case, it's TTT.tpl. And we click on, since we are not making any changes to the files as such, we can click on replace. Replace scan interval as 1, and then we start the process. So here again, we have this different type of option, which I've already shown. This comes for the first image. What we are going to do here, for the sake of simplicity, we are skipping the manual edit for subsequent records, and we click on OK. So file number 1 is completed. The file number 2 has also been completed. The third one is completed as well. In this way, all the files in the specific folders gets processed. That is, all the title blocks of all the subsequent files are recognized one after the other and indexed in the output folder. So now it's completed. We can close it, and now we can open the file, the output file, which is TTT.xlsx, and see what the result is. So as we can see, all the files that have been scanned and the title blocks that have been recognized has been appended or entered correctly into this form. Since we have chosen not to use the manual edit option, so we have skipped the editing feature. There might be some differences or corrections that need to be done manually later on, but this is what we have done in order to save our time. Okay. So this is how the entire title block recognition is done. I'm closing this. Now let's open RasterID once again. Now, one thing for sure that RasterID doesn't only have the feature for title block recognition, it also has a feature to manually extract any portion of a text within a drawing, which is essentially a scanned image, and perform an optical character recognition on manually on each of those fields. So let's open a drawing to make things make sense. Let's see. We have a good image from which we can, just a moment, please. This seems to have a number of text here as well. We can use this for demonstrating optical character recognition. So in order to do optical character recognition for discrete fields manually, we can use the OCR option, the OCR tool. Here we can use a canned header. Say, for example, we want to include the land area. Let's see, we don't have a canned header for that. We can manually write and we can do an optical character recognition. Okay, so this comes over here. Let's do it. So it comes over here. Now we can add it. Add a new record. So essentially, whenever we do an optical character recognition, the key and the fields are added as key value pairs. Basically, this is how it happens. Now we can use the key value as a covered area. We can either manually type covered area, or what we can do is we can use the title block. Sorry, I beg your pardon. The optic OCR engine. Take it. So what we do, we can paste it right here. Now let's add the area. Okay, done. So we add it. In a similar way, we can extract the text from different portion of the drawing, not necessarily the title block, using this optical character recognition. Let's say if we have something which is a big difference. Tail lobby height, tail lobby length, for example. We use this one. Now, as you can find out, this text appears in a vertical orientation. So we can go ahead and make changes to this orientation here. And then we can perform a optical character recognition. Here we can see it comes as 3.45 meter as desired. We can add it. Now, in our output template, we find 3 key value pairs. We can go ahead and make changes in their orientation. For example, the tail lobby needs to come second. So we can make it second. And this way we can make the changes here. We can also make corrections over here. So everything is possible. Now, once it is done, we can go ahead and export data to Excel. In order to do that, again, this same type of Excel output generator file would come again. We are using, say, let's use a new file for this, not an existing one. And we use the same desktop. We use a file name as T1, the existing sheet. And here we are not creating a template. We are just showing how this happens, and we click on OK. So the title block, open up this title block area, and we can find out. I'm sorry, let's open the output and see what actually has been imported in this here. Here. We had 3 fields: the land area, stable lobby length, and the covered area. All the fields and their respective values are inputted here, along with the path which shows the file path of the file which has been processed. So this is how we can make make the OCR tool work in case of RasterID. So this is pretty much some of the most important features of RasterID 2020. Hope you enjoyed this session.